All right, so we're still on implicit differentiation. I have another function. I know it's implicit because I have an x and a y in the same function, so I know I'm going to have to implicitly differentiate, find the derivative implicitly. All that means is I'm going to walk through my process. So first things first, I'm going to find the derivative in terms of x of x cubed y to the fourth equals, find the derivative in terms of x of 20. Okay, so here's where it gets a little sticky. So when you look at x cubed y to the fourth, what you see is a product. X cubed times y to the fourth. They're two different things. I can't mash them together, and I can't get out of it. So I have to use the product rule. So anytime you have two variables, different variables that are multiplied together, you're going to use the product rule. So remember, with the product rule, you need your first function and the derivative of the first function. So remember your cast of characters. You need your second function and the derivative of the second function. Okay? So the first function is x cubed. Derivative of x cubed is easy. It's 3x to the second. The second function is y to the fourth. And the derivative of y to the fourth is 4y to the third power. Okay? So here we go. There's our cast of characters. So we're finding the derivative of a product. So remember, it's the derivative of the first times the second plus the first times the derivative of the second. So remember, the derivative of the second was 4y cubed, right? 4y cubed. But because we are finding the derivative of y to the fourth in terms of x, it is 4y cubed and then dy dx. Because remember, we're peeling that 4 off. There's the derivative of the first, and then getting the derivative of the second. So we have to do dy dx. Okay? Now, anytime you're finding the derivative in terms of x and your variable is different, you will end up with that dy dx. Okay? And then the derivative of 20 is 0. Okay? So now we can simplify as much as possible, and we are solving for dy dx. So we have, I'm going to rewrite this. So we have 3x to the second, y to the fourth, plus 4x cubed, y cubed, dy dx equals 0. And all I did is I took the multiplication sign out. It just makes it cleaner. So now I'm going to solve for dy dx. That means I have to get rid of and move my 3x squared y to the fourth over. So I end up with 4x cubed y cubed dy dx equals a negative 3x squared y to the fourth. And now I'm going to solve. So I'm going to divide both sides by 4x cubed y cubed. 4x cubed y cubed. Those cancel. So I end up with dy dx equals negative 3 over 4, nothing I can do. X squared over x cubed. I have 1x on the bottom. Y to the fourth over y cubed, I have 1y on top. So remember your exponent rules. When you're doing division, you're subtracting. So 2 minus 3 is a negative 1. Negative 1 means it's on the bottom. 4 minus 3 is a positive 1. That means there's 1 on top. So that is the derivative using the product rule. Okay? Now I'm going to show you one more where you're going to have to factor. All right, so here we go. So we have x squared plus 5 equals y squared minus 3 times xy. Okay, so here we go. We're going to take the derivative of every term. Let me erase this. We might need it. Derivative of every term. So I have, do it in this way. So I have d dx of x squared plus d dx of 5 equals d dx of y squared minus d dx of 3xy. Okay? So when you get to here, if you notice, we have 3x times y. It's a product rule. So we're going to have to set that part up. So our first function is 3x. Our second function is y. The derivative of the first function is 3. The derivative of the second function is just 1. Okay, and we know it's going to be in terms of x, so we could even do 1 dy dx. We can go ahead and just write in our cast of characters. Okay, now we can go through the process. So derivative of x squared in terms of x is 2x. Derivative of 5 in terms of x is 0. It's a constant. Derivative of y squared in terms of x, so we need to use the chain rule. We peel that 2 off, and then we end up with dy dx minus, okay, so here's our product rule. The derivative of the first times the second plus the first times the derivative of the second, which is 1 dy dx. Now, notice I put it in parentheses. The reason is because I'm subtracting that whole thing off. So I'm subtracting this whole thing off. So derivative of the first times the second plus the first times the derivative of the second. So now I'm just going to clean this up a little bit. So I end up with 2x equals 2y dy dx. And I'm going to push this negative through. Minus 3y plus 3x, minus, should be a minus 3x dy dx. So what I did is I just pushed that negative through both. Okay? And this is where, if you notice, I have 2 dy dx's. Okay? So what I want to do is I want to collect all the dy dx's on one side of my equal sign, and I want to collect all other terms on the other side. So what I'm going to do is I'm going to move this 3y over. So I end up with 2x plus 3y equals 2y dy dx minus 3x dy dx. So if you notice, it's an x. If you notice, I want to solve for 1 dy dx. I can't have 2 dy dx's. So what I'm going to do is I'm going to factor the dy dx out. So I end up with dy dx times 2y minus 3x, and that's going to equal my 2x plus 3y. And now I can just divide both sides by 2y minus 3x, and I get what dy dx is. So that is my function. Now, there's nothing else I can do to this. I cannot cancel anything because there's a plus sign here and a minus sign here. These are, you have to think of that in terms of its glue that holds it together. They are not separate pieces, and they are certainly not all multiplication. Okay? All right, that's how you factor implicit differentiation.